Okay, welcome back to a new physics tutorial. In this video I would like to explain how you can do calculations with vertical shots. Just a typical example in kinematics. So we will do this as usual on the basis of a problem. So it says a man throws a stone upwards with an initial speed of 2 meters per second, when it releases the stone from the hand, from a height of 1.7 meter. What is the maximum height that the stone can reach before it falls down again? And what is the total time of flight until the stone hits the ground? Okay, maybe you have already heard a similar problem before. Maybe you know a little bit of how to calculate this, but we will go now step by step through the whole process. So after that, you will be able to calculate any kind of problem related to vertical shots with the same method. So the first thing that you will do, of course, as usual, we will draw a sketch. So now we have here our man having a stone in hand, and of course we have on the one hand the gravitation pulling downwards, so this it leads to an acceleration downwards with the g factor. And also, of course, we have an initial speed upwards, which is maybe in this case called just v0. Then what is always usually beneficial to define is the coordinate system. So again, we want to define the y axis pointing upwards, and we want to define the ground level here as y equal to 0. This will be later important for our calculation. And then another thing, the last thing which we can here define is actually the height h, which is the height between the ground and the position from where the ball is released. Now I think the sketch is more or less complete, and we can directly now start with our calculation. So I always recommend, when you have such a exercise, whether it's a vertical shot, ballistic projectile motion or whatsoever, it's always beneficial to start with the general distance time law. This is the first thing which you should always note down. So in this case, or the general form would be y of t equals 1/2 at square plus v0t plus y0. And now, of course, we know the acceleration points downwards, so we have to insert here a minus again. We know that the acceleration is the g factor, so we can replace this with g. And we know that v0 is given, and y of 0 we also know. If we take a look here in our sketch, this was given as the height h, so we can replace this with h. And then one time we can write our formula or our equation down again with the new parameter. So we can write here y of t is equal to minus 1/2 gt square plus v0t plus h. And this is now our equation from which we start our calculation. So now we start first with part A, of course, the calculation of the maximum height. And in order to do that, we first calculate the time which is required in order to reach the maximum height. So in order to do that, we first have to define a condition which has to be fulfilled in order to for the stone to reach the maximum. And we can go back to our sketch. Here you saw that the stone is thrown upwards with an initial speed v0, and then it is decelerated because the acceleration is pointing downwards, and it's getting slower and slower until it reaches the maximum. And there at the maximum height, the speed is 0, and then it starts to fall down again. So we can say the condition is that the speed of the stone at its maximum is equal to 0. So we can write here v of t equal 0. And then the question is, of course, from where we get v of t. V of t, is just not given. So we have to derive that. And this can be directly taken here from our general distance time law, because as you know, the speed is the derivative of the position with respect to time. So we can simply write here dy over dt, so the derivative of y with respect to t. And this is here given as, of course, 1/2 gt square. This, the derivative of that with respect to t gives just minus gt. The derivative of v0t with respect to t will just give v0. And of course, h can be ignored because it's just a constant value. And this means that now our derivative can be written as minus gt plus v0, and this is equal to 0. And yeah, this is then our equation which we have to solve for t. So we can just basically put this term on the other side and then divide by g, and this gives then finally a formula for the maximum time, for the time which is required to reach the maximum actually, and this is given then as this is given as v0 over g. And then we can insert our values here. We can say v was given as 2 meter per second and g was given as 9.181 meter per second squared. And you can also see from the unit at the end, second remains, so everything is perfectly fine. So when we insert here our values, then into our calculator, for example, then we get a value which is approximately 0.2 seconds. So the stone needs 0.2 seconds in order to reach the maximum height. Yeah, now we have the time which is required, but of course we want to have, or the question was, what is the maximum height that can be reached? So then the last step, of course, we have to insert this back into our distance time law, y of t. And this leads then to y of t max equals minus 1/2 gt square gt max square plus v0 t max plus h. Yeah, and now we can insert this value here. Okay, maybe one time I can just do it complete. So we have here 9.81 meter per second squared times 0.2 seconds squared plus 2 meter per second times 0.2 seconds, and then finally the height, which was 1.7 meter. Okay, and this is in principle everything. Now we can insert everything into our calculator again, and the result would be almost exactly 1.9 meter. So of course the stone was released at a height of 1.7 meter, so you can say it actually flies 20 centimeter before it starts then falling down again. Okay, so it's a quite small distance. I was also expecting more in the beginning when I created this problem, but this is actually the result which comes out from that. Okay, so part A is now completed. We know now the maximum height, and now we go to part B, and there we want to calculate the full time of flight of our stone. And again, we have to go back to our sketch. So here we saw already, or we defined here, the ground level as y equal to 0, and the stone is released from the height h, which means that we can just take now our distance time law that we have formulated, y of t equal minus 1/2 gt square plus v0 t plus h, and this has to be equal to 0, because this is just the position where the stone has to reach the ground. So we calculate now the time which is required in order to for the stone to hit ground level. Okay, and yeah, this we can easily do. I mean, we have now here an equation and a quadratic equation basically, so we can use any kind of way how to solve this, whatever you prefer, but I always like to use PQ formula, so because this is easy to remember. So we have to not divide, but actually multiply this with -2, and we have to divide it by g, yeah, to isolate t square. Yeah? And this means that now we have but t square minus 2v0 over g, t plus 2h over, and also not plus, sorry, minus 2h over g, and this has to be equal to 0. Yeah, so now we can directly take our PQ formula. If we define here this as P, and this is of course not G but Q, and yeah, then we can solve that, and we can write here T equal P half squared. So this would be V0 over G minus, this minus cancels out then, plus minus square root of P squared, P half squared. So it would be V0 over G squared, and then plus, in this case, a minus cube. So in this case, plus 2h over G. Yeah, and now we can insert all our values, which we have, and I had done this before. So yeah, you can write 2 meter per second divided by 9.1 meter per second squared, plus minus, and then of course the same thing we have to insert into our square root. So it would be 2 meter per second divided by 9.18 meter per second squared, squared plus 2 times 1.7 meter divided by 9.1 meter per second squared. Yeah, and then you can again type everything into your calculator, and as a result I got 0.83 seconds. And this is a very interesting result, just because now this is the total time of flight which the stone needs to fall back to ground. And yeah, now let's go back to our sketch. We saw that 0.2 seconds is required for the stone to reach the maximum position. Then again, it needs 0.2 seconds to reach back to the place from where it was released. Yeah, just because it's time reversible. Yeah? And if you think about this, you will come to the conclusion that it has to be like that. And then, so 0.4 seconds are gone now. And then again, it needs 0.4 seconds to reach from the position from where it was released to the ground. So in total around in total around 0.83 seconds. Yeah, this is the final result. Okay, I hope that you enjoyed the video. I hope that you learned something new. If you have any further suggestions for videos that I should show, some problems which I should solve, for example, please put it into the comment section. I will try to deal with that. And yeah, slowly you will also get prepared maybe for your examination or for your problem sheets regarding kinematics. And yeah, if you like the video, please, as usual, hit the like button. Please subscribe my channel if you have not done so far, and if you don't want to miss any further videos. Until then, see you soon.